Section 7.3 is called Angles of Elevation and Depression. This will end Chapter 7 and our adventure into right triangle trigonometry. 2 vocab words today. First one's called an angle of elevation. It's an angle formed by a horizontal line and a line of sight to a point above the line. Picture yourself looking straight forward and then tilting your head backwards as your eyes look up to the sky. That is called an angle of elevation, and the picture below, angle 1, is our angle of elevation. An angle of depression is the angle formed by looking straight and then tilting your head to look down. So it's formed by a horizontal line and a line of sight to a point below the line. In the picture below, angle 2 is your angle of depression. What do we remember from way back as a special name for angle 1 and angle 2? Hopefully you are thinking those are called alternate interior angles. And if you remember correctly, if 2 lines are parallel, which in this picture these 2 lines are parallel, the alternate interior angles must be congruent. Therefore, the angle of elevation from one point is always congruent to the angle of depression from the other point. So we got a couple problems here we're going to look at here. We're going to draw a picture, solve for the missing angle or length, and then round everything to the nearest hundredth. So the first one here, you got the picture already drawn, is an observation deck of the John Hancock Center is on the 94th floor, 1,030 feet above the ground. The sky deck of the Sears Tower, which is now called the Willis Tower, is on the 103rd floor, 1,335 feet above the ground. The 2 buildings are 1.7 miles apart. What is the angle of elevation from the Hancock Center to the Sears Tower? Okay, so we are looking at if someone is standing right there and they're looking up at this guy right here, we want to know what is the angle that they're looking at. Okay, so in order to do that, we need to have a horizontal line. Okay, so that person has to be looking straight horizontal first and then tilt their head up to look at the top of the Sears/Willis Tower. So you can see we have a right triangle formed. And it might look like we don't know any of those sides, but we actually know 2 of those sides. The bottom is 1.7 miles, but we don't want to work with miles here because we have feet everywhere else. So we need to convert 1.7 miles to feet. There are 5,280 feet in 1 mile. So if we multiply 1.7 by 5,280, we know this distance here is 8,976 feet. All right, now to get the left side, we can also get by doing a little bit of detective work. We know this whole piece here is 1,335, right? But we also know that just this piece here is 1,030. So we can take 1,335, subtract 1,030, and we know this big little piece up here is 305. Now we know 2 of the 3 sides. We don't even need to find the 3rd side. You could if you wanted to by doing the Pythagorean theorem. But the question is simply asking for the angle of elevation, which is located right there. So now we can use SOHCAHTOA, right triangle trigonometry. We're looking at the opposite leg and the adjacent leg, which is tangent. So tangent of x equals opposite leg over adjacent leg. Because we're looking for that angle, we're going to use inverse. So tangent inverse of 305 over 8976. And we get our answer to be 1.95 degrees. Pretty small angle that we have there. Number 2, a surveyor is 130 feet from a tower. So you can see in the picture, he's 130 feet away from the tower. The tower is 86 feet high. The instrument's 4.75 feet above the ground that he's using. Find the angle of elevation. So once again, we need to start by drawing our horizontal from the top of this instrument to the tower and complete our right triangle. Once again, it looks like we don't know any of that triangle, but again, we do know 2 of the 3 sides. We know this side is 130. And to get the right side, we do what we did last time by doing 86 subtracting 4.75, and this would give us 81.25. To find the angle of elevation, once again, it's opposite leg and adjacent leg, so once again, it's tangent. Once again, it's tangent x over, or equals 81.25 over 130. So solving for that, we use tangent inverse of that number. And we can type that into our calculators. To get our angle of elevation is approximately 32.01 degrees. Example 3, a bird sits on top of a lamppost. The angle of depression from the feet of the bird to the feet of the observer below. Drew my picture wrong there, so it has to be to the feet of the observer below. Is 40 degrees. All right, so where do we put that 40 degrees? That's the big question here. So it's an angle of depression. So it must be from a horizontal line and then down, which means we need a horizontal line from the bird and then down. That is our angle of 40 degrees. The distance from the bird to the observer is 25 meters. How tall is the lamppost? We're looking for this over here. Once again, we have a right triangle, but we don't have any of the angles that we can use for SOHCAHTOA yet. We can easily find either of them. Up here, we know this is a right angle, so we could do 90 minus 40 to get 50, or we also know these two are congruent, so we can use this one as 40. Now we have a choice. Do you want to use 40 or 50? It doesn't matter. I'm going to use 40, and with 40, we have the opposite leg and the hypotenuse, which means we're using sine. Sine of 40 equals opposite over hypotenuse. Multiply both sides by 25. We get 25 sine 40 equals x. So x is approximately 16.07 feet tall. Had we chose to use 50, that would have worked just fine. We would end up using cosine then instead of sine. Example 4, a ladder leans against a house to make an angle of elevation of 78 degrees to the house. So let's put that in our picture. The angle of elevation is right here, 78 degrees. The foot of the ladder is 5 feet from the building. I already have that located right here. How long is the ladder? We're looking for this right here. So we're going to use cosine this time. Cosine of 78 equals adjacent leg over hypotenuse. Multiply both sides by x. We get x cosine 78 equals 5. And divide both sides by cosine 78. We get x equals 5 over cosine 78. And our answer here, the ladder is 24.05 feet long. All right, our last example. A little bit tricky here. The plane is 3 miles above the ground. The pilot sights Midway Airport at an angle of depression of 15. He sights O'Hare Airport at an angle of depression of 32. So you can see here, I added 15 and 17 to get 32. Okay? What is the ground distance between the two airports? So we are looking for this right here. All right, let's start here by getting all the angles that we can find. Okay? First of all, these two angles are congruent, so this one is 15. These two are congruent, so this one is 32. This is 90, of course. 180 minus 90 minus 32, this one up here is 58. And not that we need it, but if we look right here, we have a linear pair. We can do 180 minus 32 to get 148. That one. So now we have all the angles we need in the picture. All right, let's start by looking at this big orange triangle. And we're going to get this big orange segment that we will call X. So it's going to be tangent 15 equals 3 over X. So X equals 3 over tangent 15, which is 11.20 miles. All right, now we can look at this little angle, this little triangle here, and this side, which we'll call Y. So to get Y, we're going to do tangent 32 equals 3 over Y. So Y equals 3 over tangent 32. So Y is approximately 4.8. So if this big distance is 11.2 and this distance is 4.8, to get the distance, we can do distance equals X minus Y, which is 11.20 minus 4.80. And our distance is approximately 6.40 miles. Okay, the last two pages are practice problems. So I'd like you to go ahead and try those last two problems, last two slides. And once you finish, you can come back and check the answers. Here's your answers to the first slide, problems A through D. And your answers to the number 2, 54,115 feet. That'll do it for Chapter 7. It's the end of our adventure in SOHCAHTOA and Wright